Hello children, I am here with another video of mole concept, and here we will start from percentage composition and we will do empirical and molecular formula also. Percentage composition, it is the percentage by weight of each element present in the compound. Okay, so where whatever element is present, you have to take out the percentage for each element that is present in the given compound. And its formula is percentage of element is equal to mass of element in the compound upon mass of compound, that is total mass of compound, into 100. Let's take the example of water. Let us suppose in water hydrogen mass is 1 and oxygen is 16. You have to calculate the percentage of oxygen. And what is the formula? Mass of element in the compound. So oxygen is 16. How many atoms of oxygen? Only 1. So you will write directly 16. And mass of compound, what you will write here? Mass of compound is hydrogen is 1. How many atoms of hydrogen? 2 plus oxygen, 1 atom is there, so you will write 16 into 100 is equal to 16 upon 18 into 100. On doing the calculation, you will get the value 88.88%. Now let's take another example of sodium chloride. You have to calculate the percentage of chlorine. Sodium atomic mass is 23. Chlorine is 35.5. Percentage of chlorine in the compound. You have to write mass of element in the compound, that is 35.5 only, because one atom again is here, and upon 23 plus 35.5 into 100. Now you will get 35.5 upon 58.5 into 100, and after calculation you will get 60.68%. Clear? One more example is here, children. We will do now this bigger one. Now next question is sodium carbonate crystals, that is dot 10 H2O is attached with sodium carbonate, and you have to find the percentage of water in it. Okay, so children, always follow the steps, because in exam there is step marking also. So first thing you will write what is given in your question. So given part, sodium is 23, carbon is 12, oxygen is 16 and hydrogen is 1. This is your given part. Okay, now second step is formula. What formula you are applying for this question. So first step, second step, you will write percentage of water is equal to mass of water upon mass of Na2CO3.10H2O into 100. This is two steps. Okay. Now third step is for calculation. Calculation part will start from third step. So children, these two steps also carry some marks. Depend upon the number, what marks is for that question. Okay, sometimes it is of half marks for this step, half marks for this step, and rest of the marks is for calculation and final answer. Now here you will write percentage of water is equal to mass of water is hydrogen is 1 into 2 and oxygen is 16. So this will be the mass of water. But how many water molecules are present in the question? See here, 10 molecules. So you will multiply this water by 10. And now mass of sodium carbonate crystals. So sodium carbonate Na2CO3 is 23 into 2 plus 12 plus 16 into 3. You will get 106. Okay. So here 106 plus 180 into 100. Okay. So now you will get, after doing the calculation, 180 upon 286 into 100. Now after doing this calculation, the final answer what will come, that is 62.9. okay, this is the percentage of water. And here when you will come here, then you will get the full marks. Okay, and suppose you have done calculation till here, or it is in the fraction like 22.7 or 180 upon 286, only like this, so you will not get the full marks. You have to reach here in the decimal form, then only you will get the full marks. Okay children, so try to do practice in the step form so that in exam you can write in steps only. Okay, I suppose you all have understood this, the step marking. First you will start from given, then formula. You just simply write the mass of element is equal to mass of element, percentage of element is equal to mass of element upon mass of compound into 100. Okay, so here you can score marks, and final is calculation. Let's calculate mass of sodium, percentage of sodium in sodium carbonate crystals. Okay, so mass of sodium is 23. How many atoms of sodium is here? 2. So you will write 2 into 23 upon 286 into 100. So you will get the percentage of sodium. Okay, like that you can calculate for oxygen also. Percentage of oxygen, oxygen mass is 16. Okay, how many atoms of oxygen is here? 3. Okay, so you will write 3 into 286 into 100. This will give you the percentage for oxygen. Now next is empirical formula. It is the simplest formula of a compound in simplest whole number ratio of atoms of different element which is present in one molecule of compound. Let's take some example of empirical formula and molecular formula. Suppose we are taking hydrogen peroxide, H2O2. So empirical formula will be the simplest formula for this. So you will take out the common factor from here. What is left? Only H and O. And what common factor you have taken out? 2. Let's take another example, C6H12O6. Now again you have to simplify this ratio, 6, 12 and 6. So you will get here, you will take out the common factor 6 from here. What is left? CH2O. Again suppose we are taking C2H6. So what common factor you can take out from here? Again we will take 2. What is left behind? CH3. So you can say that the empirical formula is the simplest form of molecular formula. Whatever molecular formula is given, you have to just simplify it and you will get the molecular formula. So you can conclude that, suppose here what common factor you are taking out? 2. Here also, here 6 and here 2. So you can say that molecular formula is equal to N, this represent N, into empirical formula. Okay, clear? One more thing you can conclude from this, here it is that mass of this empirical formula mass is 1 plus 16, that is 17. Okay, and here this mass is 1 into 2 plus 16 into 2. So now what you are getting, 2 plus 32 is equal to 34, and here after doing the multiplication with 2 you will get 34. Okay, so here also 34, here also 34. So you can conclude, or you can take one more example. CH3, carbon is 12, hydrogen is 3. So here you can say 12 plus 3 is 15 into 2. This side you will get 30. And again for this C2H6, C2 is 12 into 2 plus 1 into 6. 12 into 2 is 24 plus 6 is equal to 30. Again both sides it is 30. So you can say that molecular weight is equal to N into empirical weight. These two formula you can conclude from the equation, first and second. Now let's begin with the numerical based on these equation. Empirical formula of two compounds is same, that is CH, and its vapor density is given 13 and 39 respectively. Okay, find the molecular formula. You can say that empirical formula is this CH for two compounds. Vapor density is 30. One more formula you have learned with molecular formula is equal to 2 into vapor density. So from here you can calculate for first compound vapor density will be 2 into 13, that is 26, and for second compound vapor density will be 2 into 39, that is 78. For molecular formula for first compound and molecular formula for second compound. Okay, now empirical formula weight. See here, CH is given empirical formula, so empirical formula weight is equal to, what will be the empirical formula weight, children? 12 plus 1, that is 13. Now to find out the value of N, you have to, N is equal to molecular weight upon empirical weight. Okay, so for first compound N1 is equal to molecular weight is what? Molecular weight, this one is for first compound 26 upon 13, that is 2. Okay, and this is the value of N, and in the just now we have learned that molecular formula is equal to N into empirical formula. So value of N we have got from this equation, that is 2, and empirical formula is given in question, that is CH. So the molecular formula will be C2H2. Okay, for first compound. For second compound, N is equal to 2. It is clear to you all? Empirical formula is given in your question. Empirical formula weight, you will calculate. Mass of carbon is 12 and hydrogen is 1, that is 13. Okay, molecular formula is 2 into vapor density. 2 into vapor density for first compound, vapor density is 13, so molecular formula weight will be 26, and here you will write weight, and second is 39, so 2 into 39 is 78. So N you have to calculate to find out the molecular formula. So you will write molecular weight upon empirical weight. So this is your molecular weight, that is 26 for first compound. So you have written 26 over here, and empirical weight, that is 13 given in the, see you have calculated here with empirical formula. So 26 upon 13 you will get 2, And the molecular formula for first compound is N into empirical formula. The value of N you have calculated here. So 2 into empirical formula, that is CH, so it will be C2H6. Now for second compound, N is N2 and N2 again molecular weight. So here it is 76 upon, again we will write 13. So you will get here 78 upon 13, you will get 6. The value of N is 6. So molecular formula is equal to 6 into empirical formula. Now you will get C6H6. So first compound is ethine and second is benzene, C2H2, and second one is C6H6. Now next question is calculate empirical formula and molecular formula with percentage composition. It is given for carbon 26.59, hydrogen 2.22 and oxygen 71.19, and vapor density is given here, that is 45. So you will write your answer like this. First column element, second is percentage composition, third atomic mass, fourth atomic ratio, and fifth is simplest ratio. So element we are having carbon, hydrogen and oxygen. So write here carbon, hydrogen and oxygen. Percentage for carbon it is 26.59, hydrogen is 2.22 and oxygen is 71.19. Okay, atomic mass of carbon is 12, hydrogen is 1, oxygen is 16. Now atomic ratio, children. Atomic ratio is just the formula of mole, given mass by molar mass. And if it is in the percentage, so you will write percentage upon mass. So here you will write 26.59 upon 12, just like moles. Okay. And here second one you will write 2.22 upon 1, and here is 71.19 upon 16. Here you will get 2.216, here 2.22, and here 4.45. After calculation you will get this. Now children, simplest ratio, you will take the smallest one, smallest value which is coming after this calculation. So smallest ratio is 2.21. So you will divide this 2.216 upon 2.216, and because this one is very smallest among these three, so all of these value will get divided by the smallest value. 2.216, 4.45 is again get divided by the smallest number, 2.216. Okay, so now here you will get 1, here it is also near about 1, and here it is 2. Okay, so after getting these values, you can write the empirical formula. Empirical formula: carbon, number of atom is 1, hydrogen it is again 1, oxygen it is 2. So you can write CHO2 is the empirical formula for the given compound. Now you have to calculate. Empirical formula is done, molecular formula also. So the molecular weight is equal to N into empirical weight that we have done in the previous one. Empirical weight will be 12 plus 1 plus 32 for this. So 32 and 1 33, 34, 35, 45. Okay, so N into 45, you will get this molecular weight. But what is the value of N over here? In your question, one more value is given, that is vapor density. And you all know that molecular weight is equal to 2 into vapor density. Okay, so in question vapor density is 45, so you will write 2 into 45. that is 90. So now you have molecular weight also, that is 90. Put the value over here. Now you can get the value of this n, that is 90 upon 45. You will get 2. So now molecular formula is equal to n into empirical formula. This one is also one. Sorry children, one more time I am going to repeat this. Molecular weight is equal to n into empirical weight. Molecular weight we can calculate from this. In your question 45 is given the value of vapor density. Molecular weight is equal to 2 into vapor density is equal to, you will get 2 into 45, 90. So you will put the value of molecular weight over here, and n into 45 will be the empirical formula weight. The value of n you will get from here, 90 upon 45, that is 2. So the value of n is 2. Now in your question you have to calculate for molecular formula also. Empirical formula you have calculated, that is CHO2, and molecular formula is n into empirical formula. Now children, the value of n you have calculated 2. So put 2 over here. Empirical formula is CHO2. So it will be like this. And now multiply this 2 by the empirical formula. You will get C2H2O4. So this will be the molecular formula for the given compound. Okay. So molecular formula is this. Empirical formula is CHO2. This is your solved question. Okay. Molecular formula is C2H2O4 and empirical formula is CHO2. Let's take another example of this numerical. It is an organic compound in which hydrogen is given 2.22%, oxygen is 71.19%, and rest of the percentage is of carbon. So you can say that 100 minus percentage of hydrogen and oxygen will give you the mass of carbon. So after doing the calculation, you will get the value 26.59% for carbon. Okay, this is 9. Now again you will do the same thing. Element, that is carbon, hydrogen and oxygen. Second is percentage. Carbon is 26.59, hydrogen is 2.22 and oxygen is 71.19. Next is atomic mass. Carbon is 12, hydrogen is 1, oxygen is 16. Now next is atomic ratio. Atomic ratio is mole also. Atomic ratio you can learn it by like this, given mass by molar mass. So 26.59 upon 12. Here it will be 2.22 upon 1, and here it will be 71.19 upon 16. Now after doing the calculation you will get 2.22 here. Here it is 2.22 only, and here it is 4.44. Now next is simplest ratio. Simplest ratio, what you will do, you will take out the smallest one from here. Here these two are smallest, so it's fine, you can take any one. 2.22 upon 2.22. Divide all these number by smallest number. Okay, 4.44 is divided by smallest number. Okay. Now here it is 1, here it is 1, here it is 2. So empirical formula will be C. Carbon is 1, hydrogen again 1, and oxygen it is 2. So empirical formula you are getting CHO2. Now the empirical formula mass you have to calculate. 12 plus 1 plus 32, that will be 45. Okay. So it is empirical weight. You have to calculate empirical formula that you have done here, and molecular formula. Molecular formula is equal to 2 into vapor density, and in your question vapor density is given 45. So 2 into vapor density is 2 into 45 is equal to 90. Okay, so vapor density you are getting 90 over here, and molecular formula is equal to N into empirical formula. This is also termed as molecular weight is equal to N into empirical weight. So you have to calculate the value of N first. So molecular weight you are getting 90. So N is equal to 90 upon empirical weight is 45. So value of N you will get 2. Now put or multiply this 2 by empirical formula. So molecular formula is equal to N into empirical formula. The value of N we have calculated 2, and empirical formula is CHO2. So molecular formula will be C2H2O4. Okay, C2H2O4 you will get the molecular formula. So you will get molecular formula is here C2H2O4 and empirical formula is CHO2. Now one more question is, an organic compound having oxygen 26.24%, hydrogen is 4.92. So see children, here it is not mentioned rest is of carbon. So you have to be very alert here that while calculating the percentage you will add these percent. 26 and 4 is 30 or 31 only, but where is the rest of the mass? So you have to use your mind and you will write carbon for rest of the percentage. Okay, so here you can write carbon is 68.84%. Okay, so this is the complete question. In exam only these two part is given and it is organic compound. So rest of the percentage is 100 minus oxygen plus hydrogen percentage. So you will get the percentage of rest, that is carbon here. Now find the empirical formula. Here it is. First you will write element, then you will write what element are here, carbon, hydrogen, oxygen. Percentage, carbon is 68.84, hydrogen is 4.92 and oxygen is 26.24. Next is atomic mass. Carbon is 12, hydrogen 1, oxygen 16. Next is atomic ratio. Atomic ratio is moles given mass or percentage upon molar mass. You will write 68.84 upon 12, 4.92 upon 1 and 26.24 upon 16. Now you will get the values. Here it is 5.74. Here it is 4.92. Here it is 1.64. Now children, take out the smallest value, that is this one only. So here simplest ratio, you will divide all these three number by smallest number. So 5.74 will get divided by 1.64, 4.92 get divided by 1.64 and 1.64 get divided by 1.64. So now after doing the calculation you will get here 3.5, here it is 3, here it is 1. Now children, this ratio, this simplest ratio will be in the whole number ratio. So here it is 3.5, that is not whole number. So you have to make this a whole number. So you can do this by multiplying this by 2. So if you are multiplying this by 2, you have to multiply all other number also by same number, that is 2. Okay, So here you will multiply 3.5 into 2, so it will be 7. Here it will be 6 and here it will be 2. So 7, 6 and 2. So carbon is 7, hydrogen is 6 and oxygen is 2. This one is your empirical formula. Clear? In the simplest ratio you will take whole number. In atomic ratio you will take smallest number, and atomic mass is the mass of each element. Percentage is given in the question.